In this module, I'm going to introduce the notion of rules of inference and how we can write what we'll call formal proofs. This module is, in some sense, one of the topics that students often find challenging. There is often confusion about what is expected and what is it that you're allowed to do and what is it that you're not allowed to do. And so I want you to sort of focus on how we design these rules of inference and how we use them in writing proofs. What you would need to do is to be able to use the rules of inference to write proofs, and I'm going to talk about how you can go about doing that. This thing is in sections 1.6. To figure out where we would want to write proofs, first look at the notion of logical implication. So the logical implication, the question is, when does premise 1 imply conclusion 2? So you have some well-formed formula 1 and you want to know whether it logically implies formula number 2. To do that, we can write the truth table for formula 1 and formula 2, and what we want is we want to make sure that we don't have this situation. This situation must be disallowed. That is, we want to make sure that there is no situation where formula 1 is true but formula 2 is false. That's what we want to do. Now let's look at how these questions are related to each other. So one question we can ask is, does P logically imply Q? Is proposition P implies C a tautology? Is the proposition not P or C a tautology? Is not C implies not P a tautology, or is P and not C a contradiction? Now, the short answer to this is that all these questions are identical. That means if the answer to one question is yes, the answer to the other questions is yes, and vice versa. Now, when we write a formal proof, where our goal is to show whether P logically implies C, whether P is some premise, C is what we'll call conclusion, a proof is equivalent to establishing a logical implication chain. That means in every step you want to make sure that the next step follows from the previous steps that you have done so far. Given a set of premises or hypothesis, so we'll use the word H1, H2, H3 up to Hn to describe the different hypotheses. And if our goal is conclusion C, then to give a formal proof, essentially what we have to do is establish that the hypothesis logically imply the conclusion. In other words, we want to prove that this formula is true. That means if I start with a scenario where H1, H2, H3 up to Hn all are true, then it must be the case that the conclusion C is true in that situation. Now, to do this, what we are going to do is we are going to create a finite chain where the finite chain will be of the form some formula P1, some formula P2, keep going. Eventually at the end we want to have the conclusion C that we want to prove. Now, so far all that we are requiring is that this chain consists of well-formed formulae. Now, clearly we could have well-formed formulae that are just random well-formed formulas. So we have to have some constraints on what they can be. And what we want about that is we want to follow one of two rules. Rule number one is each of this premise is either a premise. So sorry, each of the formula that we write is either a premise or a tautology. So I'm allowed to write down any of my premises that I have anytime I like. I'm also allowed to write any of the tautologies that I may have. So, for example, just because I felt like it, I could write a formula P or not P, or I could write any other formula that is always true. The second rule is PR can be written if PR is logically implied by one or more propositions that come before it. So if I could show that some propositions that came before PR logically imply PR, then I can write this formula PR. So essentially, what we want is anytime I write a proof that is a logical implication chain, I want that each of those propositions, each of those well-formed formula that I'm writing are going to be true given the hypothesis that we have. The notion for the proof in the textbook is like this. You start with some hypothesis, then you write some other formula that you can derive from that hypothesis. Once in a while, you write one more hypothesis, then you write some more formula that you utilize both of these hypotheses that you have, uh, and derive some more formula. Keep doing this until you reach a situation where the last formula that you write is the conclusion, and at this point, your proof would be complete. Once again, we have reached one of this check before you go ahead slide. So what I want you to get from this module is, what is a proof? Well, a proof is a logical implication chain of logical implications where each statement follows from the previous statements. I want you to know what are two types of statements that can appear in a proof. Recall that one of them was a premise or a tautology. Premise was something that was given to you, so as far as the proof is considered, that is a true statement, and tautology by definition is true. Or a statement that follows from previous statements, and this is where most of the proof complications or innovations are going to come